This question was asked in the GATE Physics paper 2020. This is a MCQ type question having 2 marks. The question is from the topic solid state physics. The question is, consider a one-dimensional non-magnetic crystal with one atom per unit cell. Assume that the valence electrons, number 1, do not interact with each other, and number 2, interact weakly with the ions. If n is the number of the valence electrons per unit cell, then at 0 Kelvin, option A, the crystal is metallic for any value of n. Option B, the crystal is non-metallic for any value of n. Option C, the crystal is metallic for even values of n. And the last option, option D, the crystal is metallic for odd values of n. So, let us see which option is correct. So, here we are given one-dimensional non-magnetic crystal has one atom per unit cell. Let the atom have n valence electrons. Now, there are two assumptions we have to consider according to the question. Those are, there is no interaction between electrons, so no electron-electron interaction. And the second assumption is electrons have weak interaction with the positive ions, that is electron-ion interaction. So, these are the assumptions basically we consider in the root theory of metal. Now, we can have either even values of n, that is number of valence electrons per atom, or odd values of n. So, for even values of n, if we choose n equals to even value at T is equal to 0 Kelvin, these electrons will make either a covalent bond or van der Waals bond. Example, silicon, germanium, carbon, this type of atom has 4 or even electrons in their valence shell, and they make covalent bond with their 4 nearest neighbors. Now, the second case, odd values of n. If we choose odd values of n, then at T is equal to 0 Kelvin, the electrons will make either ionic bond or metallic bond. Since here we have only one atom in the unit cell, that is monoatomic basis, while bonds require two electronegative and electropositive atoms in the crystal. So, ionic bonds are not possible in our case. In this case, most favorable bond is metallic bond. In the metallic bond, the outer energy levels of metals atoms, the s and p orbitals overlaps. The electron participating in the metallic bond is not shared with a neighboring atom, nor it is lost to form an ion. Instead, the electrons form what may be termed as electron sea, in which valence electrons are free to move from one atom to another. Let us consider some example. Sodium, which has valence electrons n equals to 1, aluminium, which has valence electron n equals to 3, silver, which has valence electron n equals to 1, gold has valence electron n equals to 5. So, all these elements are basically metals having odd number of electrons in their valence shells. So, sodium, aluminium, silver, gold, etc. are few metals in which total number of valence electrons are odd. So, the one-dimensional crystal will be metallic for odd values of n, that is odd number of valence electrons in the valence shell. So, our option D is correct. So, we have solved this question and we found that the last option, option D, the crystal is metallic for odd values of n, that is the correct option.